Next is SRSWR, which is simple random sampling with replacement. In this case, n types n possible samples of size n from a population of n can be drawn. So each sample has a probability of 1 over n by n of being chosen, pi, but each unit will have the same 1 upon n probability of being chosen. Although in practice it is almost never done, but the expression of standard error and estimated standard error are simpler with SRSWR. So if y bar is the sample mean and S square is the population variance and small square is the sample variance, then sample mean is unbiased estimator of population mean, or y bar is equal to y bar hat, and value of the sample mean or the variance of y bar is S square by n 1 minus n. So if that is the variance, then the standard error of y bar is just going to be S square upon n 1 minus n, and its estimator, the estimator will be small s square upon n 1 minus 1 over n. Now compare this to the standard error, the variance. So variance is this, but let's look at the variance in SRSWR. The variance of y bar here is S square, variance is this, while the variance of in SRSWR was S square upon n minus n upon capital N. So what that means is that the variance of y bar under SRSWR is n minus n upon n minus 1, because these two expressions are the same. It's only this which is different, times the value under SRSWR. Okay, so variance of y bar under SRSWR is n minus 1 times the value under SRSWR. And WR also has a y hat which is going to be n y bar, and the estimator of standard error, which is just going to be just n square small s square small n 1 minus 1 upon n. So what is this? This is the estimator. So we know that y hat is equal to ny bar, and the variance of y bar is this thing. Variance of y bar is this thing, is s square upon n 1 minus 1 upon n. So what will be the variance of y hat, because y hat is going to be n times is variance of n times y hat, and that n becomes n square, and variance of y hat, which is just this number, but if we want to do an estimation of it, instead of the capital S it's going to be the small s. So small s, this thing small s upon n 1 minus n, and if we want to do the standard error, this is going to be the under root of this thing. So that is the standard error estimator of standard error of y hat, or total values. So in another thing here is, in SRSWR it is possible that all sample units are not distinct. So y bar d is denotes the mean of distinct units. Then it can be then we can prove this, that the variance of y bar distinct is less than variance of y bar, and this we can prove it mathematically.